says we've got a curve, the curve is y equals 2x squared. So if we sketch that curve, something like that. It says points A and B lie on the curve and x coordinates, and have x coordinates 5 and 5 plus h. So let's put 5 roughly here, and so 5 plus h can be there. So there's my A and B. So we've got 5 here and 5 plus h here, and the curve is y equals 2x squared. We can work out the y coordinate of A just by substituting 5 for x. So that's going to be 2 lots of 5 squared. So that's going to be 20. So my graph's a bit out of scale, but it doesn't really matter. So we know that A is 520. Sorry, 550. B is going to be difficult to work out, but we're going to need it because we want the gradient. We want the gradient of that line there. So we're going to need the change in the y direction. We can see that the change in the h is just going to be 5. Sorry, h, not 5. We know that gap's 5, but we need to know what this gap is. So we're going to need to know what the y coordinate is for B. So we are going to have to work it out. So it's going to be what we get when we substitute 5 plus h in. So when x equals 5 plus h, y is going to be 2 lots of 5 plus h all squared. So we've got another square bracket to expand. It's really worth in core 1 learning how to do these quickly. I'm going to do this one quickly. It's going to be 25 plus 10h plus h squared. So if we double that, that's obviously going to be 50 plus 20h plus 2h squared. So now we can do the change in the y direction divided by the change in the x direction. Another 2, y2 minus y1 over x2 minus x1. So we've got 50 plus 20h plus 2h squared, take away 50 for the y coordinate of A, divided by x2 minus x1, which is 5 plus h minus 5, which we've already said is h. The 50s cancel, so we're left with 20h plus 2h squared over h. We can factorise out a factor of h, so we've got 20 plus 2h over h. Those h's all cancel, and we're left with 20 plus 2h, which is what it wanted.